Welcome to lesson 11.3. We're going to find the area of regular polygons. This presentation is going to be a little bit different because I do this lesson differently than is in the book. Therefore, I actually skip the warm-up exercises. If you want to do this, though, you can do these. See if you got them correct. Okay. Make sure you know how to work your scientific calculator, you know how to do these problems. But to get into the lesson here, we're going to learn about the apothem of a polygon. And that is going to be the distance from the center of the polygon to the middle or to the midpoint of each of the sides. We're talking about regular polygons. So each of these regular polygons can be divided into congruent isosceles triangles. When we divide these into multiple congruent right triangles, just congruent triangles, we can also figure out the measure of this angle. In this case, this is a pentagon, so there are going to be a total of 5 congruent triangles. This is obviously a circle. 360 divided by 5 is 72. So each of these angles is 72 degrees. Eventually, though, I'm going to have to find the height of this triangle, so I'm going to draw the apothem. I'm going to draw this, and that's going to work as an altitude. Since it's an isosceles triangle, it's also going to work as a perpendicular bisector. These are going to create two 90-degree angles. These pieces are each congruent, and each of these angles are congruent. So since this whole thing was 72, that's made up of two 36-degree angles. Okay, we could also find the measurement of the other angle here, because if this was 36 and this was 90, we subtract and we get that GAF here, this angle is 80 degrees. You followed all this. In this case, this is a square. So there's 4 congruent triangles inside of it. This is 90 degrees. This angle is also 90 degrees. So this part here is 45, and then this would also be 45. Okay, they talked about the names here. So the center is a radius would be PY, another radius would PX. The apothem is PQ, and the central angle is XPY. And then we went through, we just did on the last problem because I did the wrong answer. XPY, the central angle is 90 degrees, and each of these is 45 degrees. In this lesson, we're going to learn how to find the area of an n-gon, or basically any regular n-gon. I'm going to go through how to use this formula and how to get this formula, but then I'm actually going to solve these problems by finding the area of congruent triangles and multiplying by how many there are, because you may get problems involving composite figures where it's not a perfect regular polygon. So the first thing you need to understand is that the apothem of the polygon, of the regular polygon, so basically from the central angle to one of the sides, is also going to be the altitude of an isosceles triangle. In this shape here, if I continue drawing the sides, we would have a regular hexagon, so that could be divided into 6 congruent, that's a bad drawing, but 6 congruent triangles. The apothem we can use to then find the area of this triangle. Base times height, 1/2. So if we look at the formula, if we take half of the apothem, remember, to find the area of a triangle, base times height. So in this case, we're taking 1/2 of the height, and instead of taking the base, we multiply by the perimeter, because in this case, that's going to be 6 of the bases. We would get the total area. I do this a little bit differently, same concept though. I find the area of one of the triangles, that's 1/2 base times height, and then I multiply that by however many number of sides there are in the regular polygon, because that would be the number of congruent triangles. So I'm going to do it the way that I do it in class, but if you do not take my class, if you watch this video and you have a different teacher, understand that they might be using this formula. So we're going to actually look at how this works in reality. Here we have a top of a table that's an octagon, and they tell us that the distance from the central angle to the vertice is 19.6, okay? And then the length of one side is 15. So basically, if you can picture this, I'm going to have, since this is an octagon, 8 triangles. This side length is 19.6. The base is 15. I need to find the height, I want this in blue, or the apothem. So when I split that in half, I actually have made 2 congruent right triangles. The base of this right triangle now is 7.5 because it's half of 15, and this is 19.6. So I can actually do 7.5 quantity squared plus b squared equals 19.6 squared. Getting out my calculator, 7.5 squared, I'm just move this down here, is 56.25 plus b squared equals 19.6 squared, 384.16. So 384.16 minus 56.25 is 327.91. And I want the square root of that, and that's about 18.1. So now if I go back to the original triangle, that would be like this here. The base is 15. The apothem, or the height of the triangle, now is 18.1. So 18.1 times 15 is 271.5 divided by 2 is 135.75. There are actually 8 of these, and so the total is about 1,086. Okay, I had a little bit different of rounding because I did 18.1 instead of 18.108. They've used here a little bit of a different situation. There was 15 was the side length. There were 8 of those sides for a perimeter of 120. 1/2. Really what you're doing here is 1/2 times the entire base, all of those 8 put together, times the apothem, the height. In the example I just gave you, they actually gave you 2 of the dimensions of the triangle. They gave you the base and the slant height. Here we have triangles that have just a slant height of 4. We don't know the apothem. We do not know the bases of these. We know that it's a nonagon, so 9 sides. Since it's 9 sides, it's 9 congruent triangles that all have a vertex angle here that's formed by the center of the circle. And the circle is 360 degrees. So 360 divided by 9 is 40. This whole angle here is 40. When we divide that in half, we get 20 degrees. So now we're going to need to use some trigonometry, and since I do not have trigonometry on the calculator that I use on my presentations, I'm going to use calculator off screen. And I first decide I want to find this base length. And I think my slate just died. So I want to find this base length. I'm going to have to do some typing here. And I'm going to call this x. So I'm going to have, this is the side opposite the 20-degree angle, and this is the hypotenuse. So when I'm dealing with opposite and hypotenuse, that's sine. So the sine of the 20-degree angle is equal to the opposite divided by 4. Now, off screen, you can't see this. 20 sine is 0.3420. I'm going to multiply both sides by 4, and that's going to equal x. So this number times 4 is about 1.37. So this base is 1.37, this part here. So the entire length here, now granted, my calculator is actually still having it 1.36808, blah, 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 blah. I'm going to multiply that by 2 to take care of rounding issues. So I actually get 2.7, type 3 by accident, 2.736. And I want to get rid of that type here. Is the length of one side of the nonagon. Now I'm going to go back. I'm going to use a different color so you can follow this. And I'm going to find this side length. I'm going to call this, now I'm going to call this x again. I'm solving again. It's a different x. Make you feel better, I'll call this b. So this is now the side adjacent to the 20-degree angle. I'm going to use cosine because I use cosine when I'm adjacent, and that's b divided by 4, which is the hypotenuse. In my off-screen calculator here, 20 cosine is 9397 is what it's going to round to, but I have that all in my calculator here, times 4, and I'm going to get that the height here is 3.758, which is going to round to 3.76. So now, come over here and use this calculator to find the area of this triangle. The height, 3.76, times the base is that number, divided by 2 is that number. Remember now, there's 9 of these. So we get a total area of 46.3 is what it's going to round to. And they can go through the work here. They obviously used a different formula than I did, but the work is done exactly the same way. We're going to just review a little bit here, and this is some more triangle practice. Find the perimeter and the area of the regular polygon. Well, I first need to find this base. So I have a triangle that has side lengths of 6.5, and that's going to be Cronny squared plus b squared is going to equal 8 squared, and in this case I can do this quickly, is 64. So over here on my calculator, 6.5 squared is 42.25. And put this down here. Oops. Oh, I just lost what I wanted. So 6.5, let's clear this. 6.5 squared is 42.25 plus b squared equals 64. So 64 minus the 42.25 is that number. I need the square root of that. So I'm looking at b is equal to about 4.7. I'm going to leave that in my calculator. So because there's actually two of these. So I keep hitting the wrong button here. My slate is not working. 9.33. There's going for one side. There's going to be 5 of them. So 9.33 times 5 is 46.65. So the perimeter is 46.65. Now remember, this is not, though the perimeter is not how I find the area of this pentagon. I'm going to go back here. Remember, I have a base here in one triangle of 9.33 times a height of 6.5 is that number, divided by 2 is 30.3225 times 5. So the area of this pentagon is about 151.6 units, okay? Oh, and this was 46.6. I think I mistyped pulled out the wrong number here when I had those extra digits. But remember, I don't use this finding the perimeter. I use it finding the area of the triangles and multiplying by how many there are. One other guided practice example, find the perimeter. So I have a triangle that has a base of 7. When I break this in half, it's going to be 3.5. Now, I can use trigonometry because I can find the measure of the angle at the top here. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. 360 divided by 10 would be 36, and then 36 divided by 2 is 18. So we have an angle there with a measure of 18 degrees. I'm going to be doing some work off track here. So let's first say I want to find the measure of C. I have the side opposite, use the text box here. I am dealing with the opposite and the hypotenuse. So that's going to be the sine of 18 is equal to the opposite divided by C, which is the hypotenuse. In my calculator here, the sine of 18 is 0.3090. That's going to equal 3.5 divided by C. That's going to be the same as C is equal to 3.5 divided by 0.3090. And 3.5 divided by 3090, 3.5 divided by 0.3090 is 11.33. So right here, that is the length there. But now that I'm looking at this, I realize I didn't even need to find that length. I only needed to find the length of the apothem. But I'm going to do that now. So now I'm going to be finding the side adjacent to the 18-degree angle. So since I'm going to be dealing with adjacent and opposite, that's the tangent. So the tangent of 18 is 3.5 divided by the adjacent. In my calculator, the tangent of 18 is 0.3249 equals, actually, times A will equal 3.5, which means A is going to equal 3.5 divided by 0.3249. And in my off-screen calculator, 3.5 divided by 0.3249 equals 10.77. So 10.77 is the height, or the apothem. Now to find, I'll use this calculator to find the area of each of these triangles. It's 1/2 base times the height. The base is 7. The height is 10.77 divided by 2, and there's 10 of these. So the area of this shape is 376.95, which will round to 377 units. So now we are going to do the daily homework quiz. Find the measure of the central angle of a regular polygon with 24 sides. So that's going to be 360 degrees. 24 sides means there's 24 triangles. You can divide it into 24 spaces. So the central angle is going to be 15 degrees. Find the area of each regular polygon. So in this case, each of these sides are 8. So base times the height. 8 times 5.5 is 44. Divided by 2 is 22 times 5. So there's a total of 110 degrees. When you have that dot there, that's the height, that's the apothem length there. So that's the height of that triangle. This problem is going to get a little bit more complicated, and I'm not sure which way they want it, but since they're giving me 6 radical 3, I'm going to assume that they want this answer in simplest radical form. So I can right away see that this is probably a 30, 60, 90 degree triangle, because 6 would be the side across from the 30. 6 times radical 3, x times radical 3 will be the side across from the 60, and the hypotenuse is twice the length of the shortest side. So this entire base of this triangle is 12. 12 times 6 radical 3 is 36 radical 3. And there are 6 of these. So 36 times 6 is 216 radical 3. If the answer under here is rounded to the nearest hundredth, that's going to be 3 square root times 216 for an area of 374.1. And here are the pages that have the problems for your homework. I hope you've enjoyed.